welcome once again. So we were discussing asymptotes and curve tracing. We have discussed what is an asymptote and how to draw and how to find the asymptotes. Now we will discuss how to draw a curve. First we are discussing the Cartesian curves and not the polar curves. So this is a very important and very interesting topic of mathematics. All other coming topics like calculus, integration, they are based upon this. So the fundamentals should be very strong for you. If a new curve comes to you, you can easily draw. You cannot memorize the curves. A few can be done, but if you get a new curve to be drawn, then you cannot draw this if you are not clear with the concept. So the concept should be very clear to you. So I will discuss the step-by-step process of drawing or tracing a curve. There are few steps. First is symmetry of the curve. Symmetry, that is having the same shape on both sides. So we have to check the symmetry about x-axis, about y-axis, about the line y equal to x, and in opposite quadrants. So if all powers of y in equation of the curve are even, no odd power of y, then symmetric about y-axis, x-axis, sorry. If we have all powers of x as even, then this is symmetrical about y-axis. Suppose we have y square equal to 4ax. Very simple example, a parabola. Power of y are all even, no odd power, so it is symmetrical about x-axis. Same on both sides. If you have x square equal to 4ay, symmetrical about y-axis, because the powers of x, all power of x are even. Then if x and y replace each other and no change in equation, in that case it is symmetrical about the line y equal to x, like xy equal to a constant c, or x square plus y square plus 3axy equal to 0. Then you can see if you replace x by y, y by x, equation remains unchanged. What is xy equal to c? This is a rectangular hyperbola. Similarly, this curve. So if x is replaced by minus x, y is replaced by minus y, and there is no change in the equation, then symmetric in opposite quadrants. So if you replace xy minus x, y by minus y in these equations, the equation remain unchanged. Similarly, this ellipse is also of this type, so they are symmetric in opposite quadrants also. So this is the first point, symmetry you have to check. After this, the second step is to check whether origin lies on the curve or not, and this you can do by checking whether there is a constant term in the equation or not. If it is having any constant term, that is, it is not involving x or y or any other variable, that is called a constant term. Suppose I have y equal to 2x plus 3. This is the constant term. It means that this line is not passing through the origin. If I have y equal to 2x only plus 0 as constant term, this is passing through origin, but this one is not passing through origin. So second thing is to check the origin, whether it is lying on the curve or not. Now after this, when you find that the origin is lying on the curve or not, We have to find the equation of tangent to the origin. First, find origin, whether it is lying on curve or not, then tangent at origin. So how to find the tangent at the origin? So you can find the equation of tangent to the curve at the origin by equating to 0 the lowest degree term in the equation. Put lowest degree term in equation 0. Suppose y square is equal to 4ax. This is a parabola, and I told you that it is having no constant term, so it is passing through the origin. What is the lowest degree term? Lowest degree term is x. This is having degree 2, this is having degree 1. So if I put x equal to 0, that means y axis is a tangent. So this is the shape. At the origin, y axis is the tangent to the curve. Similarly, if I write y equal to x cube, the lowest degree term is y is 0, and this is passing through origin. Y equal to 0, that means x axis will be the tangent to the curve. Now there can be one tangent or more than one tangent. In that case, the origin is called a multiple point. Origin is a multiple point if having more than one tangent. And according to different conditions, it is known by different names. This is called node, then this is called cusp or isolated point, if the tangents are distinct, that means you can find the separate equations of these two, real and distinct, then it is called a node. Real and distinct tangents, two separate tangents. Suppose the shape of curve is like this. So this is this axis is the y axis is the tangent at this point. So it is having two tangents which are real and distinct at the origin. So it is called a node. And we call it cusp if the tangents are coincident, and if they are imaginary, then isolated point. So you should ascertain first of all about the tangent at the origin. Then we have to find intersection. Next step is intersection with axis. So for x-axis, put y equal to 0, and for intersection with y-axis, put x equal to 0. Find the points of intersection of the curve. This is very simple step. X square upon a square plus y square upon b square equal to 1. If I put x equal to 0, then y is plus minus b. If I put y equal to 0, x is plus minus a. After this step, we will check the existence of the curve, up to which point or in what region the curve is existing. For this you have to check the values of x and y. For what values of one, the other will be real. So regions of existence of curve. Now suppose we have the equation of the curve x cube. So it is cutting the axis. If you put x equal to 0, then y is equal to 0. So it is cutting the axis at origin. and if you put y equal to 0, in that case x will be 0. So it is meeting the axis only at the origin. Now what are the points of existence? Y is equal to x cube over 1 minus x under root plus or minus. So here you can see under root cannot be negative, so x should be positive. Now x can be equal to 0 here, so x should be greater than equal to 0. Denominator cannot be 0, so x cannot be equal to 1, and x should be less than 1. So it exists for the values of x equal to 0 included, 2x equal to 1 which is excluded. So it is existing between x equal to 0 to 1, but x equal to 1 it is not going to touch. So you can say that x equal to 1 can be an asymptote to this curve. So this will be the next step. After this we have to find maxima minima if required in the curve to draw the shape and the point of inflection. What is the point of inflection? Maxima minima and point of inflection. Maxima minima means if you put dy by dx equal to 0, then you will find second derivative of this, whether it is 0 or greater than 0 or less than 0. So if it is greater than 0, then the function is having a minimum value at that point, and if it is less than 0, it is having maximum value. Means what is the maximum existence of the curve? Point of inflection is known as a point where the curve changes its shape. Suppose the curve is like this. So at this point, till this point, we have the slope in this form. This is less than 90 up to this point, and after this the slope is changing, it is more than 90. At this point the slope is 0. So this is called the point of inflection. So at this point the curve is changing its shape. So here you will find the critical points at which y may be maximum or minimum for any particular value of x. Then we will find the asymptotes as we have discussed previously, and sometimes it may be necessary to simplify the equation by converting this into polar form, x equal to r cos theta, y equal to r sin theta. Sometimes this may be required. This is the last step if required. Otherwise we have to follow these steps. So these are the steps for drawing or tracing a curve. Let us discuss a few of the examples. The first equation is one step we have missed. When you find the intersection with the coordinate axis, I will discuss this also when I trace the curve. So at those points we have to find the equation of the tangents. Here we will be shifting the origin. How this can be done, I will just explain. The equation of the curve is a square x square equal to y cube to a minus y. So first point is symmetry. Here it is having, if you multiply this, power of y is odd, and here it will be even, and x is only even. So all powers of x are even, so it is symmetrical about y axis. First point. Second thing, origin lies on this or not. There is no constant term, so passes through origin. This is the second thing we can check. And now we have to find the tangent to the origin, equation of tangent to the origin. What is the lowest degree term in the equation? Lowest degree, this is third degree term if you multiply by 2a, and y4 fourth degree. So lowest degree term is this, x square. So equate to this to 0, the lowest degree term. So tangent at origin, x square equal to 0. This gives x equal to 0, x equal to 0, y axis. But we are having two values which are similar to each other. So origin, you can say, is a cusp. After this, we have to find where is the curve meeting the origin. So curve meets the origin if you put x equal to 0. Then y is 0 and 2a. So it is meeting the origin, the axis at 0, 0 and 0, 2a. Now we have to find the equation of tangent at these points, at the origin and at 0, 2a. So at the origin we have found the equation, that is the y-axis. So shift the origin to 0, 2a to find the equation of the tangent. So shifting the origin means if I shift the origin 0, 0 to hk, then x will be x plus h or xy here, and y will be y plus k. So I am shifting the origin here to 0, 2a. So x, y will become x and y plus 2a in this equation. So ax square equal to y plus 2a cube, 2a minus y minus 2a, or ax square is minus y into y plus 2a to the power 3. This is the equation of the curve with origin shifted to 0 to 2a, because we have to find the tangent at that point. Now at this point, equate to 0 the lowest degree term in the equation. This is second degree, y into y second degree, and y into, if you expand this, you will find that the lowest degree term here in the equation will be y. So putting y equal to 0, lowest degree term in this equation, this gives x-axis. So at this point 0, 2a, the tangent to the curve is parallel to the x-axis. This is the meaning of this. Now after this we have to find the existence of the curve. We can draw the shape also together. This point is 0 and 2a, and here the tangent is parallel to the x-axis, and this is symmetrical about y-axis, so the shape should be like this. It passes through origin, and at origin this y-axis is the tangent. So x equal to 0, x equal to 0 means on both the sides. So here the shape must be like this. And we have found the existence of the curve. The equation a square x square is equal to 2a minus y. So y cannot be greater than 2a, it can be equal to 2a, and y should be positive, cannot be negative, because then x will not be real. So 0 to 2a, existence of the curve. Now if you find dy by dx, so differentiate the equation, 2a square x equal to 2a into 3y square dy by dx minus 4y cube dy by dx. So dy by dx is 2a square x upon 2 3a y square minus 2y cube. So this is equal to a square x over y square three a minus 2y. So if you put dy by dx equal to 0, you will get x equal to 0, and here the tangent, here we have drawn the shape. Now, so this step is you can check for the maximum value of y. What is the maximum value of y for this? And apart from this, you can put various values of y for this to find the shape of the curve and get the values of x for different values of y. So if I have y equal to say a by 2 or y equal to a, suppose if you put y equal to a here, so a square x square equal to a cube into a4, so x equal to plus minus a. So if y equal to a, this is 2a, half of this, then x will be plus a and minus a, plus a and minus a. If y is equal to a by 2, in this case a square x square equal to a cube by 8 into 2a minus a by 2, 3a by 2. So x is plus minus root 3a divided by 4, and root 3 is 1.73. So this is equal to plus minus 0.4 a around approximately. So x is a by 2, y is a by 2. This is a, this is half of this a by 2, 0a, 0a by 2. In that case, the value of x is 0.4a approximately. This was a, half around here approximately. So you can see the shape of this curve will be like this. At this point here somewhere, the shape of the curve is changing. So this will be the point of inflection. So the point of inflection you can find by equating dy by dx. Now dy by dx here will not be 0 because the curve is symmetrical to y-axis. So for this, dx by dy should be 0 because the tangent is, because the line is perpendicular to the x-axis. So it is making an angle 90 degree with this. So dy by dx is tan 90, that is infinity. So dy by dx tends towards infinity, means dx by dy is tending towards 0. So we will write that opposite of this, dx by dy equal to 0. So this gives us y square 3a minus 2y over a square x equal to 0. So y is 0 and 3a by 2. So y is 0 this point and 3a by 2 somewhere here. So it means this is y equal to 3a by 2, and for this if you check the second derivative, this should be also negative. And the value of x at y equal to 3a by 2 is given by y cube. You will put 3a by 2 here, 27a cube by 8 into 2 minus 3 by 2 a by 2 divided by a square and under root of this plus minus 3 root 3 by 4a plus minus. So it will be around 1.2a. So here you can find, so this will be the shape of the curve. This is how you can draw the shape of the curve. Let us discuss another example. The equation is 4ay square is equal to x into x minus 2a whole square. So how to draw this curve? First of all, symmetry. Here you can see the power of x will be even as well as odd. All powers of y are even, so it is symmetrical about the x-axis. Half on this side, half on this side. Now see whether it passes through the origin or not. It is not having constant terms, so yes, it is passing through the origin. Now the equation of tangent to the origin you can find, how I told you. Equating to 0 the lowest degree term in the equation, the lowest degree term is x. X equal to 0, that is y-axis tangent to the curve at origin. Y-axis means shape of curve will be like this. Same on this side, same on this side, and touching y-axis at the origin, passing through the origin. Now where it is cutting the origin, the axis, meeting the axis. So it is meeting the axis. If you put x equal to 0, then y is 0. And if you put y equal to 0, so one point is 0, 0. Then x is 1 is 0 and 2a. So 0 and 2a. 2a and 0. These are the points where it is meeting the axis. And now we can find the equation of the tangent at the point of intersection with the axis. 0, 0 we have found. Second is 2a 0. Suppose this point is 2a 0. So we will shift the origin here. So x will be x plus 2a, y will be y plus 0 in the equation. So the equation becomes 4ay square x plus 2a x plus 2a minus x whole square, or 4ay square is 4a square x plus 2a, or y square equal to a x plus 2a. This is the equation of the curve if we shift the origin. So now equate the lowest degree term in the equation. What is the lowest degree term? On the side of y, we have y square as the lowest degree term. Check for x, what is the lowest degree term in x? This is x plus 2a minus 2a whole square. So this is equal to x plus 2a into x square. So lowest degree term here is y square, and on this side we have x cube plus 2x square. So x square into 2. So equate this to 0, y square and x square into 2, 4a, this is 4a y square. So 4y square, and this is minus, if you write this on, bring this on this side of the equation, so 4y square minus this 4y square a minus 2a x square equal to x cube. So this is the lowest degree term of the equation. Equate this to 0, so you get y equal to plus minus x by root 2. So y equal to mx. So slope of the line is, these are two perpendicular lines to each other. Slope of the lines, one is 1 by root 2, other is minus 1 by root 2. And you know that tan 45 is 1, and then tan is increasing, tan 60 is root 3. So the lines y equal to x by root 2 will be like this, and y equal to, other line is perpendicular to this, y equal to x by root 2, y equal to minus x by root 2. These are the tangents to the curve at this point. Now after this we have to check the existence of the curve. So x should be positive for y to be real. That means existence means x should be greater than 0 on this side only. X cannot be 0, less than 0 here. So it is existing on this side. And then find dy by dx equal to x into 2x minus 2a plus x minus 2a whole square into 1 divided by 8ay, and equating this to be 0, we get x minus 2a, 2x plus x minus 2a equal to 0. So x is 2a and x is 2a by 3. X equal to 2a is this point, and x equal to, we take another point, x equal to 2a by 3. So at x equal to 2a by 3, y is, if you find the value of y by putting the value of x in this equation, this is 2a by 3 root 2 by 3. It means that for x equal to 2a by 3, somewhere here the value of y is maximum. So you can take different values of x between 0 and 2a, and then plot and find different values of y and plot the curve. Here it passes through this point, touches, and shape is like this. How we find the shape of the curve of these two, this branch and this branch, is like this. So you can see when x is equal to 2a, x equal to 2a here, y 0, it is cutting at this point. If x is more than 2a, then y is monotonically increasing, means strictly increasing. What is the meaning of that? For strictly increasing function, f dash x is positive. So when x is greater than 2a, y is strictly increasing on this side as well as on this side, because this is symmetrical. So it is like this, it is touching this line here. So this is how you can draw this curve. Let us discuss the next question now. The next question is, draw the curve y square into x plus a equal to x square into 3a minus x. This we have to draw. So first of all, check the symmetry. So you can see that it is symmetrical about the axis of x, that is all power of y are even, x is having power 3 here. So symmetrical about x-axis, half on this side, half on this side. Then second thing is whether it passes through origin. Yes, because there is no constant term in the equation, so it passes through the origin. What is the tangent at the origin? So put the lowest degree term in the equation equal to 0, tangent and origin. So lowest degree term y square x is 3 degree, y square is 2 degree, so y square a, and x cube is 3 degree, so minus 3a x square equal to 0. All second degree terms, so y is plus minus root 3x. There are two lines which are perpendicular to each other, which are tangent. So one is making 60 degree angle and other is 90 plus 60, 150 degree angle with the x-axis. So these two lines are tangent to this at the origin. This is one line, this is other line. Y equal to x root 3 and this is y is minus x root 3. Now after this, find the points where the curve meets the origin. If you put x equal to 0, y simply is 0. So one point is 0, 0. If you put y equal to 0, then x is 0 and 3a. So other point is 3a 0. So we have to find the tangent we have found at origin. At 3a 0 we have to find. So shift the origin x to x plus 3a, y to y plus 0 and write the equation y square x plus 3a plus a x plus 3a whole square into 3a minus x minus 3a equal to x plus 3a whole square into x, and this with a minus sign. This is the shifted equation in which origin has been shifted. And now equate to 0 the lowest degree term. And what is the lowest degree term here? X equal to 0. So the tangent at 3a 0 is x equal to 0. That means y-axis is the tangent at this point. That means parallel to y-axis. So here suppose we have 3a 0. The curve is passing through this and this is the tangent. That means the shape of the curve, it is touching this, is like this. Similarly, it is touching these lines, so it should be somewhat like this, and on this side also. Now we have to check the existence of the curve. If you have x equal to minus a, then x equal to minus a, then y is not real. Y does not exist. If x equal to minus a, that means the curve does not go beyond x equal to minus a. This is x equal to minus a. So it means that the curve is not touching this because x can never be equal to minus a. So x equal to minus a will be an asymptote to this curve. This will be an asymptote to the curve. After this, the next step, we have to find the existence. This we have found. So x should be less than minus a and x should be less than 3a, cannot be greater than 3a. So it cannot be on this side. X should be less than 3a and x should be greater than minus a. Now the shape here we have to find. So at some point here there will be point of inflection where the slope will be changing from positive to negative or negative to positive. For that case, the tangent will be parallel to the x-axis. So dy by dx will be equal to 0. So if you find dy by dx, this is equal to, differentiating simply this, 2y dy by dx equal to x plus a into 3a into 2x, 6ax minus 3x square minus x square 3a minus x into 1 upon x plus a whole square, and put this equal to 0. So you will find the point where dy by dx is equal to 0. You will get x equal to a root 3. So this is 3a, a root 3 is 1.73a, around half of this approximately. At this point, the value of x, if you check the second derivative, and that is negative, so if you find second derivative here, that should be negative for maximum value of y. For x equal to this, y is maximum, and if you put the value of x here in this equation, then in that case y is maximum, and find the maximum value is equal to minus a root 3 divided by a plus a root 3 and under root of this. This will give you the maximum value of y. So I just have to draw the shape. You can find the different values of y for different values of x here. The shape of curve is like this. So this is how you can draw the curve. So these are some of the equations which of the curves which we have drawn. We will be discussing some more forms of the curves in the next during our next discussion. So thank you very much. So if you have any question to ask, then you can please ask the question by writing in the comment box. And if you like this video lecture, then please subscribe to my channel and share it. So thank you very much. Have a nice day.